Okay, here we go. Proving trig identities. And we're going to do one more example together. But I want to talk about some tips and tricks for this. We talked about this last lesson, but I want you to look for lurking identities. A lot of times those can be the Pythagorean identities. Getting a common denominator might help. Factoring also is valuable. And then when all else fails, just get stuff into sine and cosine. So here we are with our last example for today's lesson. We've got this. The sine of alpha over 1 minus cosine alpha is equal to the cosecant of alpha plus the cotangent of alpha. So remember, we always pick one side and then we work with that one side. And I don't know. I'm more drawn to this side personally. It feels like there's more for me to do here. Like I could maybe get this into some sine and cosines and see what happens there. But maybe you're drawn to this side. Maybe you're thinking, I could multiply some stuff, maybe use some Pythagorean identities. If that works for you, cool, do it. Pause the video now and let's come back when you have attempted this and done some good work and some good thinking around it. All right, if you're back, that's because you have tried this problem, you have attempted it. Now, my first instinct is to say cosecant of alpha, well, that's 1 over the sine, 1 over the sine of alpha plus the cosine of alpha over the sine of alpha. And now when I do that, I'm like, oh, common denominator already for me. So I'm going to add these up. 1 plus the cosine of alpha over the sine of alpha. Now here, I look at this and I'm like, well, that's not the same. And I don't really know what to do. So I'm going to multiply this by a carefully chosen one. I'm going to choose a weird carefully chosen one. I'm going to choose 1 minus the cosine of alpha. And I'm choosing that because I know some difference of two squares patterns here. This is the same as 1 minus the cosine squared of alpha over sine alpha over 1 minus the cosine of alpha. Now, that gets this there, but what about this stuff? Well, if I think about the Pythagorean identity, sine squared alpha plus cosine squared alpha is 1. That means sine squared alpha is equal to 1 minus the cosine squared of alpha, which means that that's sine squared, which means sine squared alpha over sine alpha. Oops, I said it right, but I wrote it wrong. 1 minus cosine alpha. Now look at this, sine over sine, or sine squared over sine. There's some canceling that we can do. We're left with the sine alpha in the numerator, and in the denominator, we've got 1 minus cosine alpha. Check it out. It's the same. Check. We proved it, guys. We are amazing. Maybe you did something different. Maybe you kind of went with a similar approach, but did this side. I don't know. It's all great either way. Let's try some problems.